Hello, everybody at the Grid Symposium. My name is John Lilich, and I work for a company called Consensus. And we are focused on something called the blockchain. And specifically, we're working on a technology called Ethereum. I'm actually making this video recording now because I was not able to be in Japan for the Grid Symposium. Professor Abe was very kind and very gracious to invite me, but I wasn't able to attend. So I made this video with a little bit of a slideshow, and hopefully it will provide some useful information about some of our thinking in the blockchain and energy space. So I'll go ahead and start sharing my screen, and I will show you a little bit of this presentation. Okay, so 1 second here. Let me just share my screen. Okay, great. So for roughly the better part of 2.5 years, Consensus has been building out the Ethereum ecosystem. Specifically, we have been focused to a large extent on the energy sector. And more recently, we partnered with RWE, who's actually known now as Innogy, and they are the largest utility in Germany. And we started looking at decentralized propositions for the utility sector and the power sector using the Ethereum blockchain. So a little bit of an overview on what the blockchain is. Many of you have probably heard about the blockchain. You may have seen some stories in the news, some articles on the internet. And of course, the blockchain has some very interesting properties. It is a sort of distributed, shared computational network across which we can start to have peer-to-peer interactions, and these interactions have some very interesting properties. So of course, everything is cryptographically secure, meaning that data protection and just the overall integrity of the network is something we can have very strong assurances in. The system itself is decentralized, so there is no central authority, there is no corporation, there is no entity in the middle that owns the network. It is a shared sort of resource, and it is distributed around the world. The blockchain also has this notion of an immutable ledger. So when there is a transaction across this network, that transaction is recorded. It is distributed across all of the sort of decentralized computers or nodes participating in the network. They all keep a copy of the same database, and that database is very, very difficult to alter. There's also this notion of smart contracts, and smart contracts are very powerful because they allow us to execute complex business logic in a peer-to-peer context. And so, we say that the blockchain provides a trust framework that allows systems to be developed for actors to interact reliably and securely. And that has potential ramifications in the energy sector, which we'll talk about. These are just some more blockchain characteristics. It is a digitized network. It is decentralized. It is programmable and secure. And of course, it is immutable. These are all quite interesting properties. There's several different configurations of blockchains. There's the public blockchain, and so many of you have probably heard about Bitcoin or Ethereum or some of these other cryptocurrencies. And those are networks where anyone anywhere in the world can participate in the network, and they can do so in a censorship-resistant way, meaning that there's no authority that can deny you access to the network. But then we also have private and consortium blockchains, and a private blockchain is basically when we take something like Ethereum and we create our own version of the Ethereum blockchain, but the nodes that participate in that network are verified participants. So not everybody can participate on this network. It is a permissioned context, and so many corporations today are using this kind of a configuration to do a lot of testing and development and create things like sandboxes where they can build prototypes. And so also private blockchains can be much more configurable, and that's very useful in the context of regulatory considerations, for example. Okay, so we started thinking about applying Ethereum and the Ethereum blockchain to the energy sector because we believe that the energy sector is moving towards a decentralized model. And so traditionally, you would have sort of a scenario where prosumers who had photovoltaics and were generating power would sell their excess power to a direct marketer who would then sort of interact with an energy supplier, and that would also interact with distribution grid operators, and somehow eventually that energy would get to a local buyer. So all of these actors in the middle provide a service, but we think we can automate a lot of that service and program their business logic into smart contracts. And so to build the decentralized energy customer journey, we think there's some fundamental components there: decentralization, locality, renewable energy, and the sharing economy. And of course, this is technology driven and economics driven. Business models for utilities are changing very, very quickly. And so startups like ourselves are doing things like building MVPs, we're doing research, we're talking to customers, and we are building sort of next generation technologies and potentially business models for utilities. This is how we envision integrating the blockchain into this decentralized energy proposition. So now we have prosumers, and the prosumer sort of has all this data that we can collect, meter data, load profiles, etc. We can feed that data into the Ethereum blockchain and have smart contracts with business logic sort of execute the functionality that we're looking for in order to connect us to local buyers and talk to energy suppliers and direct marketers. So we think Ethereum can sit in the middle and potentially, with the power of smart contracts, fulfill a lot of the roles that utilities or other energy sector actors might be sort of taking care of today. And so within Ethereum itself, this is roughly an architectural diagram of how we imagine the future sort of looking. We have this notion of self-sovereign identity, so you can have your identity attributes and attestations resident on the blockchain, and anyone can, with authorization, if you give them authorization, anyone can validate those attributes and attestations by referencing the blockchain. And so that feeds into the prosumer who now has an identity on the blockchain, and the information from the prosumer, whether they're producing more or consuming more, can be fed into a series of smart contracts that are resident on the Ethereum blockchain. And those smart contracts can then produce business processes that look like services that financial institutions produce or deliver, utilities or telecommunications providers, etc. And so we think Ethereum and smart contracts in particular afford us the opportunity to really consider new business models and delivering new services to customers that might otherwise be cost prohibitive or too expensive. Okay, so that's just a quick wrap up. We didn't have very much time, but I wanted to just give my contact information here and also let everybody know that Professor Abe and his team at the University of Tokyo are doing incredible work, and they are probably the best sort of people to talk to in Japan about decentralized energy propositions. And we are continuing to have conversations and looking forward to working together more closely in the future. If you're on Twitter, you can find me here at John Lilich. Otherwise, my email information is there, and I visit Japan very often and hope to see some of you very soon. Thank you very much.